Hello there. From atoms to computers 1. Atomic structure. What is it about the nature of atoms and molecules that makes electronics possible? At the core, electronic systems are, for one, powered by electricity, and secondly, manipulate the flow of electricity. What I'm referring to as electricity in this case is actually electric current. The difference is that electricity is a form of energy possessed by charged particles, while current is the movement of these charged particles. So, for electronics to operate, we need to utilize these charged particles to provide the electricity that will power and be manipulated by these electronic devices. And this is where our understanding of the atom and its atomic structure comes in. Their atomic structure. The atom is the building block of reality. The atom is composed of subatomic particles, neutrons, protons, and electrons. It is here that we find the charged particles that we desire to utilize in our electronic circuits. Electrons have a negative charge and protons have a positive charge, while neutrons are neutral. The charge is an inherent property of these particles and was baked in as or before the universe was created. The Bohr model. The structure of an atom can be represented by a central nucleus containing neutrons and protons with electrons orbiting this nucleus. Electrons are arranged in orbits with inner orbits filled with electrons first. Since protons in the nucleus are held together tightly by the strong nuclear force, only the negative electrons can be utilized for electric current in wires. However, charged ions, which are atoms or molecules which have an excess or deficiency of electrons, hence a positive or negative charge, are also used for electric current, but this is not as common. So how exactly do electrons go from orbiting the nucleus of an atom to being used in our electronics? The quantum mechanical model. Before we answer this question, we'll first understand the true nature of an atom. The Bohr model is a useful visualization, but in reality electrons are not arranged in neat orbits around the nuclei. Instead, electrons are contained in electron probability clouds called orbitals or subshells, not to be confused with the aforementioned orbits. An orbital or a subshell is a region in space where one would expect to find an electron. Due to wave-particle duality, i.e., electrons acting like both a particle and a wave, it is impossible to exactly determine where an electron is. Thus, a more realistic representation of an electron is the quantum mechanical model. Electron energy levels. Orbitals or subshells are contained in discrete energy levels called shells. The further the shell is from the nucleus, the higher the energy state of the electrons in the shell. The electrons in the outermost shell of an atom, which are called the valence electrons, can interact with each other to form atomic bonds, creating different materials. The nature of the bonds formed between these atoms is what determines whether the electrons in the material can produce an electric current when a voltage is applied. Atomic bonds. Okay, so again, how exactly do electrons go from being in these electron clouds around the nucleus of an atom to being used in our electronics? The answer is in the way atoms bond. Atoms bond in three ways. An ionic bond. An atom with outer electrons donates all of them to an atom that needs electrons to complete its outer shell. In covalent bonding, however, two atoms that both need outer electrons share electron pairs to complete their outer shell. In both these bonding types, electrons are generally held tightly together and thus cannot be utilized for electrical conduction. Metallic lattice. However, in the third type of bonding, metallic bonding, atoms release their outer electrons and bond to form structures with a repeating pattern called a lattice. The valence electrons in this structure can move freely within the lattice and are typically described as a sea of electrons. It is these free-moving sea of electrons that we can easily utilize for electrical conduction. The metallic material is held together due to the electrostatic attraction between the positive metal ions and the sea of electrons. Conductors, insulators, and semiconductors. A more complete picture of what determines how free-moving the electrons are in a material comes with a clearer understanding of the quantum nature of electrons. Electrons can only be in specific discrete energy states. Again, this is due to wave-particle duality. Now, when a structure of a material interacts with this energy distribution of electrons, it forms regions that electrons cannot occupy. Think of it as the lattice of a material disrupts the traveling wave of an electron, and thus electrons cannot exist in that energy level in the lattice. This forms what is known as a band gap or an energy gap, with the levels below the energy gap referred to as the valence band, as we discussed earlier, while those above are called the conduction band. For a material to be able to conduct electricity, electrons need to be able to accept energy from an electric field by moving into higher energy levels. This is only possible if there are empty energy levels in the material, since only two electrons can occupy a given energy level. In conductors, the valence band and the conduction band overlap. Thus, there are many empty energy levels for electrons to move up into. For insulators, however, the valence band is completely full, and there is a large band gap to the next energy levels in the conduction band. Hence, it is extremely difficult for electrons in an insulator to accept energy from an electric field and thus conduct electricity. There are materials which have full valence bands, but only a narrow band gap between the next energy levels in the conduction band. These materials can conduct electricity if sufficient amount of energy is supplied to them. As such, they are referred to as semiconductors and are the foundational material of electronics and computers. Semiconductors will play an extremely important role in future lessons. For now, we can just note that they can control the flow of electrons depending on how much energy is applied to them. In the next lesson, we shall understand what exactly an electric current is and what exactly is going on in a conductor when current is flowing through it. Kindly subscribe to follow along.